All right, guys, this is a little extension on section 2.1 talking about truth tables. So I'm going to fill out these notes here for you today. So the truth table, the truth value of a statement is either true or false. You can determine the conditions under which a conditional statement is true by using a truth table. The truth table below shows the truth values for the hypothesis P and conclusion Q. All right, so P to Q, our implication here, our conditional, P to arrow Q. So first off, these two columns will always be the same. These are all your possibilities when you're talking about the bimodal situation here, P and a Q. They can either both be true, you can have a true and a false and a true, or two falses. So you're always going to start out your first two columns with those four possibilities. All right. And then when you get into P arrow Q, the only situation that leads you to a false is when true goes to false. So we talked about this on the 2.1 notes, and basically it's a true hypothesis and you're contradicting it with a false conclusion. That's no good. That's where we have the false situation, and it's right here for you too. The only false is when you have a true hypothesis producing a false conclusion. So it might seem weird, but when you have a false hypothesis, you're going to end up with true implications. All right, so let's make these truth tables here. All right, so a converse. Now what did we do? We flipped. It's Q arrow P. Now, we don't need any more columns because all we need is a P and a Q, and we have that. Again, true, 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 false, false, true, false, false. Always starting out with that. Now, when I look at Q to P, though, I'm going backwards. So a true to a true gives me a true. A false to a true also gives me a true. Aha, here's the true to false. That's where I get a false. And then a false to a false gives you a true. Inverse. So now check this out. You know what the inverse is. It's not P to not Q. So if I need my answer to have a not P and a not Q in it, then I got to have a column for a not P and a not Q. So the original two columns are not enough for me. So how do we fill these in? Well, not P just looks back to normal P and flips the signs on everything you see there. So a true gives you a false gives you a false gives you a true, and a false gives you a true. Now with Q, not Q, I'm going to look back to normal Q. So a true gives you a false gives you a true gives you a false, and a false gives you a true. And now when I'm filling the inverse out, it's not P arrow not Q. So I'm going from the not P column to the not Q column. A false to a false is a true. A false to a true is also a true. A true to a false. There's my false scenario. Ugh, what was that? And then true to a true gives you a true. Now we talked about logically equivalent statements. The converse and the inverse are logically equivalent, so TTFT for both of them when you're filling out the truth table. Now the contrapositive, it also wants a not Q and a not P. It's just flipping the order of them. So the contrapositive flips it and negates it, so let's fill this out. Again, I need a not Q, so I got to have a column for that. I need a not P, I got to have a column for that. Not Q is going to look back at normal Q and flip all of them. Not P is going to look back at normal P and flip all of them. Now once you have those two columns built, now we can fill out what we're after. Not Q to not P. False to a false is a true. True to a false, ooh, bad news. That's your false. False to a true is true. True to a true is true. So TFTT will look the same as TFTT because the contrapositive and the conditional are the same, or they're logically equivalent. All right, guys, pause the video and try 14 and 15 based on these rules of logic. All right, so here we are. So let's see here, making this truth table. I know, oops. So P, Q, so I know it's true, 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 false, false, true, false, false. Those are my scenarios. Now look at what I need. P, I already have that. I need a not Q column in this case. So let's build one. Not Q is going to look back at normal Q. False, true, false, true. Flips all those ones before it. Now I can go straight to my answer because I have everything I need to go from P to not Q. So this over here to this. Ooh, bad. True to a false. That gives me a false. True to a true is a true. False to a false is a true. False to a true is a true. So false, true, true, true would be the truth table for P, arrow, not Q. And 15. Making a truth table here. Always start out with P to Q, true, 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 false, false, true, false, false. Now I want, well, okay, check this out. This is not the same as this. There's no distributive property in the world of logic. So instead, what we want to do is find what P arrow Q is, and then we can negate that whole column whenever we do the negation of P arrow Q. So let's fill out P to Q. So true to a true, true to a false, there's our problem. False to a true, false to a false, so there you go. And now we can just flip all of those. It's going to look back at this column and flip it. So false, true, false, false. All right, so that's truth table logic in a nutshell, friends. Peace!